Welcome to Shanti-Peace for Mathematics. In this video, we are discussing about the solution for this problem. With this problem belongs to finding the maximum and the minimum value of the function. The problem says that a rectangular box is open at the top and have a volume of 32 cubic feet. So you have one box, rectangular box is there, and this box is open from the top. This is the box and it is open from the top. Its volume is given as 32 feet. Find the dimension of the box required a least material to construct it. So let us assume that its length is x, so this length is x, breadth is y, and the height is z. So x, y, z are three parameters of this problem. Now what is the surface area of this rectangular box? That you need to make it list because you want to construct this box. So the surface area of this box will become, see, this side is x, y, and this is x, so that's why it is xy is there, which is only coming one times. This side is coming two times. Here is also the same on the opposite direction. Also we have them, so that is 2 of x, 2 times xz, and the same scenario with this side, that is yz is there, which is coming 2 times, so it is 2 times yz. So that is the surface area, and that function you want to make it minimum. And what is the condition is given to you is the volume is 32. That means this product of this three value is 32. Now we need to calculate what is the extremum value of this function, that is s is equal to this xy plus 2xy plus 2yz with the given condition this. So whenever this type of situation is there, it is better to use the Lagrange multiplier method. The working rule for Lagrange multiplier method are this. First you need to calculate what is f. F is fxx, that is your function, and this is the given condition. Obtain these values, that is fx, fy and fz at 0, 0, and solve this three equation with this power of x, y, z is equal to 0. Those the point which what is the solution is given, or whatever the solution is obtained by this, that are the stationary points or extreme values of that function that we can say. So here your function f of x, y, z is this, that is xy plus 2yz plus 2xz, and the phi of xyz, which is given you the volume is 32, that is xyz minus 32. So I am writing f, that is f plus lambda phi, which is xy plus 2yz plus 2xz plus lambda xyz minus 32. So first you need to calculate fx is equal to 0, which gives you 2y plus 2z plus lambda yz. That will give you lambda equal to y plus 2z upon yz minus del f upon del y equal to 0 implies x plus 2z plus lambda xz implies lambda equal to x plus 2z upon xz minus, and del f upon del z equal to 0 implies 2y plus 2x plus lambda xy implies lambda is equal to minus of 2 times x plus y upon xy. If I call this as equation 1, if I call this as equation 2, and this will be equation 3, this is equal to 0. I forgot to write down here. Just make it correction. Now if I multiply this equation by x. I am multiplying this equation by x and multiplying this equation by y. What we will have, let us write down. So we will have xy plus 2xz plus lambda xyz is equal to 0. And the other equation will have, it is xy plus 2zy plus lambda xyz equal to 0. If I subtract these two equations, we just see that this xy is cancelled out, lambda xyz is cancelled out. So we'll have, this is minus, so it is xz minus zy is 0. So that's why z into x minus y is 0. So this will give you x is equal to y. Z will not be equal to 0 because it is the length of the rectangular box. That's why this is not equal to 0. So x is equal to y is only possible value is there. Now for further, I may multiply this equation 2 by y and the equation 3, that is this, by z. Let us write down what we get. If I write down equation 2 by y, then we have xy plus 2zy plus lambda xyz equal to 0. And the third equation, if I multiply by z, it is 2yz plus 2xz plus lambda xyz equal to 0. So you just note that this values are cancelled out. The lambda xyz is also cancelled out. So finally we will have it is xy minus 2xz is equal to 0. X is non-zero, so that's why it is y is equal to minus, so y is equal to z. So finally we will have x is equal to y already there, and that is equal to 2z. And you have xyz is equal to 32. If I substitute this value here, we will have x into y into x. The value of y is x and value of z is x by 2. So that's why it is 32. So therefore it is x cube is equal to 64, and hence this x will be 4. If x is 4, then y is also 4 and z will be 2. So this is the dimension of the rectangular box you will have. So this 4 minus 2 are the stationary points, or we can say that it has the maximum, the function has the maximum value at this point. But yet we don't know whether this gives you minimum value or maximum value. We need to observe something. So if you have a rectangular box where we have considered this is the z, if the value of z is increased for small value to the large one, that means if I increase the value from small to large one, and when z is small, the box is a flat with a large base, showing that s is large because the function s is xy plus 2yz plus 2zx. And if z is increased, then the base of the box is increased rapidly. That means this value is increased, then the height of this is increased rapidly, and s must be minimum at the some intermediate stage. So it has to be some value of z is there where the function is gives you minimum, and at that stage will be this one, that is x is equal to 4, y is 4 and z is 2. So that is the minimum value of the surface S is there. That means x is 4 feet, y is 4 feet and z is 2. That's it for this video.